The fifth task in the test was about the intervals of convexity and the inflection points of the given function with logarithm. So as usual in such task, let's start with the domain. We see that the expression x squared plus 25 is always greater than 0. So that implies that domain is set of reals. So let's calculate the first derivative of our function. This is not a product, but this is the value of the logarithm over some expression. I'm mentioning it because some students treated this as a product and wrote 1 over x times derivative of the other and so on. So this is mistake. This is composed function. This is so we need to apply the box rule. So the box rule says that we should have 1 over x squared plus 25, and then we multiply, so I may write this product here, derivative of the denominator. So we have 2x over x squared plus 25. Second derivative. Here we have the quotient, so the calculation is immediate. So after cancelling, we have 2x squared plus 50 minus 4x squared divided by the square of the denominator. So 50 minus 2x squared, like this. Okay, what is the domain of the second derivative? As we see, denominator must be different from 0, but it is even greater than 0 by the properties of the square function. So here domain is set of reals equal to the domain of function, which is perfect information, because no surprises, no extra points must be considered here. Okay, so necessary condition to identify the points in candidates for the inflection points. So we make the second derivative equal to 0. So x squared should be equal to 25, which give us two different solutions. And now sufficient condition for this, we need to investigate the sign of the second derivative, and obviously we must be careful with the order of the factors that we have here. As I mentioned before, in the solution of the inequality for the first derivative, when we consider the monotonicity, here we need to pay attention what kind of the expression should be greater than 0. Obviously, denominator is positive, so the inequality simplifies a lot. So we have a very standard quadratic inequality. So we have that 25 is greater than x squared, or if someone prefers x squared is smaller than 25, so x must be before 5 and minus 5. Okay, so the situation is following. We have 2 points, minus 5 and 5. So the table to consider the signs would be more or less following. Now let's write the signs for the second derivative. The second derivative, as we investigated between minus 5 and 5, it is positive here. It is 0 at those 2 points and negative on the sides. So what can we say about function f itself? Here the second derivative is negative, so function is concave. Here is convex and concave as well. So we see that at points minus 5 and 5 the convexity changes. So here we have 2 inflection points. And that's it. That's the whole answer.